Design and Analysis of Steering System for Solar Vehicle. Assistant Professor Mechanical Engineering Department, Phbit Sangli Tazgaon Road Budgaon Sangli Maharashtra 416304. UG Students of Mechanical Engineering, Phbit, Sangli Tazgaon Road, Budgaon, Sangli, Maharashtra, 416,304. U.G. Students of Mechanical Engineering, Phbit, Sangli Tazgaon Road, Budgaon, Sangli, Maharashtra, 416304. Abstract. This research paper aims for making prototype steering system for single-seat solar vehicle. Designs are made according to the rules and regulations of the National Solar Vehicle Challenge 2019-20. The decreasing fuel resource in the world makes it necessary to search for renewable options. This vehicle is a four-wheeler and drive by BLDC hub motor. And also driven by a battery which charged via the solar panels. We are using rack and pinion steering system to turn the vehicle. Rack and pinion steering system selected because of its simplicity, less effort, and less cost. Our project requires engineering skills according to the rules of the competition. Keywords: analysis, solar car, automobile, design, rack and pinion steering system. Introduction. The aim of steering arrangement is to turn the front wheels using hand-operated steering wheel which is in front of driver through steering column. It contains universal joint to allow it to deviate from straight line. The steering provides stability to vehicle on road. Wear and tear reduces because of steering system. It prevents road shocks reaching to driver. The steering provides self-rightening effect after taking a turn. We are using rack and pinion steering system for our solar vehicle. Because it is simple and most common in cars, small trucks, SUVs. A rack and pinion gearbox is enclosed in metal tube. A rod called tie rod connects to each end of rack. The pinion gear is attached to steering shaft. When you turn steering wheel, gear spins moving the rack. The tie rod at each end of rack connects to steering arm on spindle. The steering ratio is the ratio of how you can turn the steering wheel to how far the wheels turn. Generally lighter cars have lower steering ratios than larger cars and trucks. The lower ratio gives steering a quicker response. Smaller cars are light, that with lower ratio effort required to steering wheel is not excessive. Methodology. Material selection. We referring different literatures 1-2 and taken material as mild steel, grade 2, SAE 1018. It has generally good mechanical properties. The mechanical properties of mild steel are given below in Table 1. Table 1 Mechanical properties of MSSAE 1018. We made calculations considering Ackermann's mechanism. So we will explain all mathematical calculation by showing Ackermann diagram below. 1. Table 2 shows important parameters required to design steering system. Figure 1, Ackermann mechanism. According to rules of competition, wheelbase track width and kingpin distance selected. Wheelbase, B, equals 1700 mm. Track width, A, equals 1200 mm. Distance between kingpin, C, equals 1100 mm. Inner wheel angle, equals 300. Outer wheel angle, equals 22.360. Ackermann angle, equals tan 1, C/B. Equals 32.900. Touring radius. Inner turning radius, outer touring radius. Rin equals B/sin, dash, AC/2, route equals B/sin, plus, AC/2. Equals 3.35 m equals 4.01. Steering ratio. Maximum turn equals 250, assume, steering wheel movement equals 1800 therefore. Steering ratio, SR, equals 180/25 equals 7.2. Design of pinion. Material for rack and pinion equals mild steel, IS specifications. Minimum no of teeth for pinions. Min equals 2/sin 2, outer wheel angle, equals 17.09 equals 18. CAD modeling. CAD modeling of steering system is done using SolidWorks. Finite element models are developed using ANSI 16.0. A stress analysis can be carried out to determine stress produced in rack and pinion. Figure 2,3,4 shows CAD models of rack and pinion before assembly and after assembly. And Figure 5 shows final CAD model of steering system. Analysis of steering system. Solving theoretical calculations are tough due to complex equations, so we decide to use software for analysis and validation. Finite element analysis, FEA, is generally used. We choose ANSI APDL Mechanical 16.0 software to do analysis of rack and pinion in steering system. Table 4 results of analysis of rack. Force applied 1600 N. Max stress, von Mises, 9.830 MPa. Max deformation 0.00037 mm. Analysis of rack. It has been assumed that if maximum stress is applied on rack then it cannot break, but we apply 1600 N force because this is effort required to rotate rack as well as pinion. So considering this force we can carried out analysis of rack. As shown in figure 6. Results shown in table 3. Analysis of pinion. It has been assumed that we are applying same force of 1600 N because it has same material as that of rack. Now considering this force, analysis of pinion is carried out. As shown in figure 7. Results shown in table 4. Conclusion. We compare values theoretically and also with ANSI's software. From we can conclude that deformation produced will be negligible and it can sustain at above mentioned stress. So design is safe. The manual rack and pinion steering system not used in heavyweight vehicles due to high axle loads, but it is simple in design and easy to manufacture. Therefore it is commonly used in light vehicles.